Welcome back. We are going to take a look at arithmetic series today. So if you remember from the last lesson, we looked at arithmetic sequences, and some of the key points to those were that they always had a common difference, and that was like the first difference that we saw on the notes from 9.1, and that when we represented them visually, they would become something that was linear, with that common difference being the slope of the sequence, or the slope of the line, I'm sorry. Today we're going to take a look at arithmetic series. So if you, again, think back, but now you have to think back to 2 times ago when we talked about what a series was. So a series meant that you were taking the first however many terms of a sequence and adding them together. That is still what we're going to be doing. However, you are not going to need to know all of those terms to add them up. Instead, we're going to figure out how can we use this formula, which describes an arithmetic series, to find that sum without having to list out all the values and add them all together. So if we pick apart this formula here just a little bit, so when you have S sub n here, that would mean the sum of however many terms. So like if that was S sub 8, that would mean the sum of the first 8 terms. So sum of n terms, again, n would be a number. So n here would be the number of terms, right? And then you have 2 other pieces that you need to know. So you have a sub 1, which just like last time, that's the value of the first term of the sequence. And then a sub n would be the value of term n. So that n is going to carry through the whole entire thing with you. So we're just going to go ahead and try to put this into practice and see if we can make sense of it. So on example 5, it says find S sub 15, so the sum of the first 15 terms, and then it's giving you the start of the sequence that they're talking about, or the start of the series that they're wanting you to add up, however you want to look at that. So if we want to find that, S sub 15, according to our formula, is equal to n. N in this case would be 15 times a sub 1. Well, a sub 1 I know because it's given here. So that would be 25 plus a sub n. So a sub n in this case would be the 15th term of the sequence. That is not a part of what's given. You are only given the first 4 terms. So we are actually going to need to connect back to what we know from last time. So if you think back to the last lesson, in the last lesson, you were taught this formula here. And the point of that formula is that you could use it to find any term that you wanted to find in an arithmetic sequence. So the term that we want to find is term 15. So I want to know a sub 15. A sub 1, we already talked about, that's 25, plus n would be 15, so 15 minus 1, times d. So d is not stated, but hopefully you remember that if you're given the first couple terms of the sequence, you have the ability to find d. So to find d, I would take 12 minus 25. So that's telling me that d is equal to negative 13. And now we would just need to either substitute all of this into your calculator like we talked about last time, or you would just need to simplify this in order using order of operations. So either way, whatever you want to do, we need to find that value. So if we start order of operations here, you would have this. 14 times negative 13 would give you negative 182. And then if you take 25 minus 182, you're going to get negative 157. So the 15th term of this sequence would be negative 157. So if we go back over here, where we have this plus sign that I had already filled in, we really don't want a plus. We're going to want that to be a minus because it's negative 157. And then this is all over 2. So this is what we're looking to evaluate. And if we can find this value, it is going to tell us what would happen if we listed out and then added together the first 15 terms of the sequence. So again, however comfortable you are with your calculator, you can try it and see how it goes. I will show the steps for order of operations here. So if you were going to follow order of operations, you get negative 132 in your numerator. When you divide by 2, that gives you negative 66. And then you would need to multiply that by 15. So we end up finding out that the sum of the first 15 terms would be negative 990. Now, if you look at what we kind of know about the problem here, that would make sense because we know that only the first 2 terms of the sequence are positive. So at term 3, the terms start to be negative and they move on from there all the way to term 15, which remember term 15 here was all the way down to negative 157. So it makes sense that when we add these values together, we're going to get a pretty large value that is negative. All right, moving down to example 6. On example 6, you are again being told about a series, but the notation here is different. They're giving you back what we saw in the second half of 9.1, which is that summation notation. So remember that this means down here that you're starting at term 1 and going up to term 12. So what that would tell us is what we're trying to find here is S sub 12, or the sum of the first 12 terms of this sequence. Now, if I go back up to my formula, I need to know n. So n would be, what am I finding the sum of? The first 12. So n would be 12 times a sub 1. So a sub 1 is not given, but again, if you connect back to what you know about summation notation, remember that this here is your explicit formula for the sequence, meaning that you can use that formula to find any term that you want to, with or without knowing other terms. So what this is telling us is that a sub 1 would be 3 plus 4 times 1. So that would become 7. So I can fill that into my formula over here. And then it says I need to know a sub n. So plus a sub n. To find a sub n, I first need to know what n is. Remember, n is 12 in this case. And so 12 would be what I was substituting in this time. So 3 plus 4 times 12. So that becomes 3 plus 48, which is 51. So the 12th term of the sequence is positive 51. So we would have plus 51. And this is all over 2. So we were able to use what was given, again, to find our missing pieces. Now, the way that we did that was significantly different than the prior example because what we were given in the other example looked totally different than this. So now we just need to simplify. So again, if you want to use your calculator, that's fine. If you are using a calculator, you need to be putting this up here in parentheses, the 7 plus 51, just a suggestion for you to make sure you're getting this right. I will show the order of operations here for those of you that are not. So this would become 58 over 2, which is 29. And then if you do 12 times 29, you are going to get 348. So we find out that S sub 12 or the value of the sum of the first 12 terms of this described sequence is 348. Again, that seems to make sense because all of the terms are positive. We know that because the first term is positive and the 12th term continues to be positive, so they have to be going up. And at the 12th term, I'm at 51, which is a pretty large value. So that seems to be a logical answer, 348, for the sum of the first 12 terms. I'm just pointing those things out because should you get something that feels off, like if you would have gotten a sum here of 25, well, that doesn't make any sense because the 12th value, the 12th term, was bigger than the sum. That doesn't work. Or if you got something negative, that also wouldn't make sense because if I'm adding up a whole bunch of positive numbers, I cannot get something that's negative as my sum. So just think through, does your sum make logical sense as you move through those? These are our only 2 examples for today. So I have posted for you a homework assignment with solutions. You can do as much or as little of that as you feel like you need to master this content, and then show your mastery to me on the homework quiz that is posted. And then I will be back with you on Wednesday and Thursday with the first part of section 9.3. Have a great day.